Good afternoon. My name is Cesare Pautasso from the University of Lugano in Switzerland, and I would like to present you a brief history of liquid software. There are two interesting properties of liquids that we would like to bring into the software domain. One of them is their ability to flow between different devices or containers, and the other one is the fact that when they are poured in a container, liquids adapt their shape to the one of the container, and we would like the software to behave in the same way, no matter if it's running on a small edge computing device or in a larger centralized infrastructure in the cloud. So in this talk we will see how this metaphor has been used in many different ways across the past two decades. For example, if we have here many different kinds of devices, we know that user interfaces of software running in these devices can adapt its shape to the size of the display and also the kind of interaction that is available, and we call this type of application responsive. And now a liquid application would be able to adapt itself not to just a single device, but to the set of devices on which it is running on, making it a much more interesting proposition, as users have actually multiple devices, not just multiple displays, which are used to run their systems. Another example is related to the use of delivery of software in a continuous integration environment. So in this case, as we deploy a certain version of the software, then we have to typically reset and redeploy the new version to replace it. Now, liquid software provides continuous update, meaning that it can actually be installed and be upgraded without disruption. So this was another interesting definition that was proposed, and in this paper we survey many other ones. So let's try to understand what is liquidity from a quality perspective. So there are many different entities that a software system can have, and we propose in this paper to consider liquidity as a combination of flexibility, the ability of a software system to react to changes, and deployability, where we are interested to apply these changes while the software is being deployed. So if we have this situation in which we are deploying the software onto some software device, then what are the two elements that can actually change? So one of them is the software itself. So as the software is upgraded, we want the deployment of the upgraded software to be as seamless, as continuous, and with zero disruption as possible. And the other thing is the device itself. So the environment in which we deploy the software could change, and then as the device changes, we are going to adapt seamlessly the software to the different capabilities of the device. And also it's possible that not just the device will change, but there will be multiple devices involved, and as we change a set of devices, the software should seamlessly adapt to these devices. So liquid software can handle flexible deployment in the presence of changes to the software and in the presence of changes to the devices on which it is running. The liquidity of software can be measured in terms of the effort required to migrate it from one version to the next, or to migrate it from one device to another. If the migration takes time, it takes effort, if the software needs to be completely rewritten or re-implemented from scratch, or reinstalled, and the users lose all their data because of the migration, then we cannot call the software liquid. The migration of liquid software is seamless. Many authors put a lot of emphasis on the transitions that are instantaneous for the users and require zero development effort to take the software running on a small device and make it run on a bigger device. This is a key characteristic which distinguishes liquid software from solid software. These definitions are the most recent interpretation, but if we look at the past 2 decades, there has been many researchers using the term liquid in conjunction with software. We start from active networks back in 1996, or liquid load balancing. Then a few years later, liquid state machines were mentioned to refer to continuous input and a continuous set of states. There was a liquid media project at Motorola, liquid fluid computing at IBM Research, the liquid metal compiler, and also fluid architectures which can survive changes in their environment. Then more recently, we introduced liquid web services which scale across heterogeneous devices. And in 2014, the Liquid Software Manifesto was published. This manifesto focused on the multi-user experience and in the context of the liquid computing industry initiatives where users were switching the focus from their devices and their data into just using whatever devices are available to complete their tasks. This work had a very big impact in the following years in the web engineering community for the liquid web applications, liquid stream processing, liquid web components, liquid context, and liquid models, which were a precursor of today digital twins. Then in 2018, in the context of DevOps technology, the liquid software metaphor were used to refer to the concept of continuous updates. And a major PDF reader application vendor introduced liquid mode, which is a way to change the layout of PDFs to make them responsive to a small screen device. Then in the context of 6G networks, we also see the term liquid handover that was used to represent the fact that some tasks, some computational tasks can be offloaded as devices move around the network to nearby devices or to edge computing infrastructure or all the way to the cloud, which was also a concept of liquid web workers, which was proposed as a way for web browsers to offload some of their computational tasks to nearby devices. And most recently, we have liquid functions, which are a very lightweight mechanism to annotate code so that it can be deployed in the context of serverless computing, and not just in cloud infrastructure, but also on edge devices. And a few months ago, the paper on Liquid AI came out, where we have models that are trained continuously, and they're also running close to the user devices so that they preserve the privacy of the prompts engineered by the users. So this was just a brief look at the past history of researchers using the term liquid in conjunction with software, and we use this as input to come up with a definition that can help the next future research on the topic. So to conclude, we can see that there are various states of software, so we can stretch this metaphor even a little bit more. So of course we start from traditional software, which we can consider as being solid. Solid software doesn't flow and it doesn't adapt if you change the compiler. If you want to upgrade it, this is a very disruptive operation, and developers need to restart completely and reset the systems that are running it. We have seen liquid software, which can be flexibly deployed in presence of changes of the software and the containers in which it is deployed. But if you look at the physical state of matter, there is actually other states. So we could also add one more constraint to distinguish liquid software from software that runs in the cloud that has a different form. And this constraint has to do with the ownership and control over the devices on which the software is running on, which I think is also of concern if we are trying to build edge computing applications. So solid software is owned by the users, runs on their devices, and it processes their own private data. Liquid software is the same, with the interesting difference that it can actually work across multiple devices owned by the same user or owned by the same company. If we go to the third state of software, then we are running software that belongs to someone else, delivered as a service, is running on somebody else's cloud infrastructure devices, and we can question the ownership of the data that all the users are actually entrusting these applications with. So we can further refine the definition of liquidity as not just being a mix between flexible deployment, but also having an important privacy component, which should be guaranteed by liquid software. So this was a brief history of liquid software. If you're interested to know more, you're welcome to read the paper and send me an email. Thank you very much for listening.